welcome to this session as part of the Research Software Camp on collaboration and code review via GitHub. This is a session that we ran as part of our Byte-Sized RSE series that Steve and myself have been running as part of the Universe HPC project. So we've had a series of these, and if you're interested in some of the other sessions, we can point you in the direction of those later on. But as I say, today we're going to focus on this idea of collaboration in software development and code review, specifically looking at doing so via GitHub. So the way that these sessions are structured, I'm going to start off with a little bit of a sort of background presentation to give you some general information, and there'll be an interactive element as well, so you'll be able to give us some feedback on your thoughts about what you're looking to gain out of the session and so on. Then after the initial presentation, I will hand over to Steve, and Steve will lead you through a kind of interactive tutorial element to the session. And once we come to the end of that, there will be time for discussion, questions, etc. So there should be quite a bit of time for everybody to make sure they kind of keep up. And if you do have any issues with keeping up with the material when we're in the interactive part, you're very welcome at any point in time to put a message in the chat, and we're happy to take questions as we go along as well. So okay, I'm gonna kick off with this brief introductory presentation. So what I'm going to look at is just a little bit of background to coding and collaboration, quick kind of overview to what we mean when we talk about code review, and then talk about some of the processes and approaches around this topic and some of the platforms and tools that are involved. And then I will hand over to Steve for the kind of practical element. So coding and collaboration, when we talk about software development, many of you, if you are already software developers, you will find that you might be spending a lot of your time working alone writing code. But actually, when you get involved in larger projects, or indeed many kind of sort of projects in the open source community and so on, collaboration is a hugely important part of these projects and this work. So there are lots of ways that you can benefit from collaboration within coding, but equally, if you do spend a lot of your time writing code alone, you'll find that a lot of the things that we're going to go through as part of this session are hopefully still very useful to you, and there's a lot you can learn from this and a lot of different ideas that you can apply from the materials that we're going to cover. So what you will also find is that when it comes to the kind of collaborative aspects of coding, you can have a really quite large impact from a small time investment of thinking about things around kind of best practices and how you work with others when you build code. So there are many ways, obviously, to solve any kind of technical scientific problem. There's often no perfect solution, and one of the important aspects when you're doing this kind of work is being able to share knowledge and skills, share ideas and experiences, and this is something where certainly the collaborative aspect of coding becomes hugely important. So you can often find that by working with other people, you pick up new approaches that will help you to solve a challenge maybe that you another challenge that you have as part of your work, from seeing something being done in a different domain or a different field or just in a different project. So there's a lot of things that you can learn from this kind of collaborative process. And I suppose ultimately what we look at here is this idea that you can set yourself up for success in your coding activities by looking at the kind of the mechanisms and the infrastructure that you use, and helping generally to kind of learn new skills, learn new approaches, and then share these with other people. And there's a lot that can be achieved through this kind of collaborative process. So it's clear that collaboration in the context of writing code is a really important element, and it's something that can be very, very beneficial. So what do we mean then when we talk about code review? So code review is the process of, as it says here on the slide, the process of reviewing code with a view to achieving one or more positive outcomes. So basically, when you're trying to look at getting code reviewed, you're looking at being able to understand aspects of the code and assess its quality and assess whether there are particular issues, and ultimately to try and offer some sort of beneficial outcome from the process over just sitting on your own writing something and not letting anybody else see it. So the aims of a code review process, they can depend on what it is that you're actually trying to achieve. So the use case of the code being reviewed and the type of review being undertaken, because there are many different types. Code review is a very general term, and there are many different types of code review, and we'll look at some of those in a minute. But in general, it's this idea of having somebody else looking at your code and giving you some sort of feedback. But equally, if you do work solely on your own, you can still learn from this process, and there are still things that you can look at and apply in the context of having a sort of taking a kind of a view over your code that gives you a different perspective and looking at whether you can improve things. So the other point that's noted on this slide is that code review may follow a formal or informal approach, and this is something which again we'll look at in the coming slides. But ultimately, there are a number of different approaches. There is no one way to do code review, and there are formalized approaches to doing it, but it can also be very beneficial if it's done in a quite informal sort of ad hoc manner. We probably recommend that maybe if you're going to follow code review principles properly, that you take a more of a kind of structured approach. But that doesn't mean that it can't be beneficial if you do it in an informal manner as well. Okay. So what are the different types of code review? So as I just mentioned, it can be very informal, and probably the most informal type of review is asking a colleague for some advice or some input. And this is something that maybe many of us do anyway. You write something, you get a bit stuck, it's not doing quite what you want, or you've done something in a certain way and you're not sure if it's the best way to do it. And maybe you ask a member of your team, or you ask a collaborator, can they take a quick look at what you've done? Can they offer you any advice? Can you make it better? Can you, change something to make it more performant? Whatever it may be. But that sort of very informal process is still a form of code review. And in these contexts, the main focus of doing something like that is obviously this idea of trying to improve your skills or your understanding or the way that you solve problems. And this is something that I think many of us, as I say, will do without really thinking about it. But it is a very valuable option. Looking at more formal approaches, the modification approach, modification contribution-based review, as it's called here, is an approach whereby whenever changes are made to a code base, then a review process takes place. And this is a very powerful way of doing things, and it's used very widely. And as we'll see in the context of looking at GitHub a little bit later on, GitHub is very well structured, as is Git more generally. Git as a sort of a generic version control platform is very well structured to this kind of modification-based review. And what we mean by this is that if you have a piece of code and you've got it stored somewhere, perhaps you've got it stored in a software version control repository. It doesn't really matter how you have it stored, but you've got some piece of code that you've produced, and you want to make some changes to it. So as we know, you would go along, make some edits to your code. If you're using version control, which I hope you're using some sort of structured approach to updating your code. But if you're not, there's many ways to kind of learn about this, and we can point people in the direction of useful resources for that if you're keen to find out about it. But assuming that you're using some form of version control setup, you would make a change to your code. You would commit your code into the version control repository, and as you do that, you're basically making a change to the code, or proposing a change to the code, depending on the approach that you use. And this is a great time to actually do some sort of review. And so this kind of modification-based review focuses very much on this idea that every time changes are made to a piece of code, somebody gets a notification, or there's some process through which somebody is notified that the change is being made, and they go and look at those changes and they check that the changes look sensible, they don't break stuff in the repository, and that if there's any suggestions that they have on how things can be improved, there are mechanisms to provide those suggestions. So this very much suits this kind of modern source code management based workflow. And I mentioned Git and GitHub as examples, but there are many different other approaches for this. But certainly, this is probably something that I think it's very useful to learn more about and to understand. And the focus here is very much on improving the understandability and the quality of code, which I think is something which is something we can all benefit from, going forward, especially as code bases get larger and more complex and so on. It's very, very important to have that clarity in your code and ensure that it's understandable, so that when other people try to work with it, that they have some understanding of what's going on. So the third type of code review that we mention here is a much more kind of formal approach, which we class as a structured code base review, sometimes known as a failure inspection. And in this case, you have something where it really is a very, very thorough review of an entire code base. And it's a very much more traditional approach. So in this kind of setup, which is not that common, I think it was probably reasonable to say it's fairly uncommon in the sort of academic software development environment that many of us are probably familiar with. But what happens in this kind of review structure is that basically an entire code base is taken, and there is a very structured process of a group of people, potentially all kind of sitting around a table, studying an entire code base, looking for particular issues. And the criteria and the aims of the process are very clearly set out. This is, of course, hugely resource intensive, and there are benefits to this kind of thing, especially if you've got kind of code operating in mission critical environments where there are things that obviously you can't afford for things to fail, and you need to make sure that everything is very thoroughly checked and reviewed and so on. This kind of process can be beneficial, but it is very, very challenging and time consuming to manage, to set up, to handle, and particularly in things like the open source community, where you've got big collaborative projects with large numbers of people from potentially all over the world contributing things to it. This kind of approach is really much more impractical. It's not something that is generally easy to manage. Whereas the modification-based review that I talked about just a moment ago is a much better model for that kind of environment. But as I say, this structured review does have benefits. There are cases where it is very, very important to take this kind of approach. And in this kind of case, really, the main focus is much more on conformance to particular specifications and identifying defects. So as I say, if you've got code that's operating in environments where even small defects can be a hugely huge issue for you in those environments, then it's very important that you take these kind of approaches to very thoroughly check code and ensure that you can address these kind of things. Okay, so before I go on to some more detail, it's now your chance to get involved, and we're going to have a few interactive questions. So I guess many of you are familiar with Mentimeter, so this may look somewhat familiar to you in terms of the system we're using, but if you're not, if you go with your browser to www.menti.com, as is shown there on the slide, and then the code is 22768180. And that will be shown at the top of the screen when I move across to Mentimeter. So you don't have to remember it now, but I'm going to switch across to the presentation. So I can see some of you already joining. I'll give you a moment to join that Mentimeter presentation. Okay, so I will proceed, but you'll still be able to join, and the code will still be at the top of the page. Right. Okay, so this is an anonymous survey, if you want to use the word survey. Really, it's just an opportunity to understand a little bit about the audience and for you to understand who else is here and participating, and people's thoughts on the different things that we're looking at in today's session. So as I say, don't panic. Responses are all anonymous. Do try and answer truthfully. Don't feel worried that if you're answering something, you may not be following a best practice or an approach. This session is all about giving you that kind of knowledge and those skills, and it's great to understand, for myself and Steve, so the level of the audience, what you're looking for out of this session. So definitely not a test, and if there's anything that you think you're doing that may not be right, or something you're not sure about, then you're probably not alone. I'm sure there are many other people in the session who are also in the same position. Okay, so first question is, which of the following best describes your primary role? So would you class yourself as an RSE, as a researcher, as a systems or infrastructure professional, maybe, as a research manager, or some of you may be familiar with the term PRISM, somebody who's doing research management, or some other role? Of course, that could be any number of other roles. And if you've put other and you would like to tell us what your other role is, you're very welcome to put something in the chat that says what your role is. So just give people a minute to respond. So very interesting that actually the majority of people here are saying that their role is other. So it's I'll certainly be interested if anybody's happy to share what other roles people are holding who are represented here. Okay, so that's so data analyst. That's really that's great. Thank you. Yeah. So some different. So interesting that some different roles, and in fact more sort of data focused analytical roles. Great. Okay. Thank you. Thank you to everybody for answering there. I will move on to the next question. Right. So do you undertake programming as part of your role? So do you do this most of the time, some of the time, occasionally, or never? Okay, so this is perhaps more the sort of results that we would expect. So there may indeed be people here who never write code, but most good to see that many of you here, at least some of the time or occasionally, but in the case of most of you, most of the time write code. I'll just give it a minute if for anybody else that wants to answer. Right. Okay. I think that's probably all of the results in. So thank you for that. Okay. So the next question is: most of your coding done alone or as part of a team? So do you code on your own, or do you work as part of a small team, maybe 2 to 4 people? As part of a larger team, 5 to 10, or as part of a really big development team of maybe more than 10 people? And this may be a local or distributed team. Okay, so again, a really nice kind of mix there of people involved in teams of varying different sizes, but generally biased towards the smaller team size, which I guess is again perhaps what we would expect in the research software community. Okay, so I think that's probably all of the results in. So I will move on again. Okay, so now we're getting into stuff around review. So does anyone else ever look at or review your code before it's made public or used in production? And I put the point here about it being made public or used in production, but this could equally just be whether you do have code on a project, even if it doesn't get made public, that somebody else reviews. Okay, so we've got a really nice mix here. So great to see that there are some people who do actually have a structured code review process and who are always having code reviewed as part of an operating process. But also, I guess, probably as we might expect, if you're based in the research software community, this is often done much more on an ad hoc basis, and it's interesting to see that that's at the moment the majority of responses. Okay. So again, I think that's probably all of the results in. So we'll move on. Okay, so this is just really for us to get a bit of an understanding about the kind of perspective that people are joining this session from. So are you interested in this session from the perspective of somebody who's a project owner or maintainer, somebody who contributes to a project? So maybe you contribute to open source projects or to an in-house project. Maybe you're both of these. Maybe you're somebody who is both a maintainer and a contributor to projects. Maybe you are here just because you've heard about code review and you write some code and you want to find out more about it. Or maybe you have another reason for joining. And again, if you do have another reason for joining, totally optional, but you're very welcome to put something in the chat if you'd like to tell us what that reason is. Okay, so again, a nice mix, but great to see that we have many project owners here or project maintainers, and many people who are both maintaining projects and contributing. So That's really good to see. Right, okay, so thank you for those answers. We will move on. Okay. So nice to see also there from the chat, there are people who also are doing training of other people, which I think is a really important aspect. So have you created a pull request or a merge request in GitHub, GitLab, or Bitbucket, or indeed any other system before? So if you're not familiar with what a pull request is, then we will talk about that later. But in that case, I'm guessing you will probably select the never option. Okay, nice. Again, a nice kind of mix here. So many people who are using an approach to contribute changes that involve pull requests or merge requests, but equally some people who are very new to this. So hopefully you'll all gain something from the interactive part of the session and learning a bit more about these different things, whether you're familiar with the processes or not. Okay, thank you for the answers there. I will move on to the next question. Right, so this is an open-ended question, and this is the last question of this part of the presentation. So what do you find most challenging when working on a coding project? And this is your opportunity to give us just a little bit of some sort of more open text-based response about things that you find challenging. So I'll give it a minute for people to prepare some text. Okay, in fact, it's coming up straight away, which is fine. So yeah, so the first answer there, using Git. So that's definitely something which I think is a challenge for many people, because Git is such a complex tool, and there's obviously very simple use cases, but there are also some far more complex use cases. Reviewing somebody else's code is hard. Absolutely, that's a really good point, and we'll look at that again as we go through things today. It is sometimes, I don't want to, a bit of a spoiler alert, but I'd probably say that it's always something which is challenging, but there are hopefully approaches that you can use to make it easier, and sort of ways to structure things to make it easier to do. Yeah, really good point there about not having team members to help. So this is something which is often a big problem in the research community, is that if you work on research and you're a sort of sole developer within the space that you work in, it can be really difficult to not have people to talk to when you're stuck with something, and often that can be quite time consuming as well, because sometimes it's a lot easier to get somebody to help with something and ask them the question if they've hit the problem before, than it is to spend hours trying to solve it yourself. So a number of other things. Thank you very much to everybody who's provided the answers here. So working with legacy code, absolutely, that's a challenge. If you haven't coded collaboratively before, that's really big problem. It's something that there's a lot to learn. It's definitely true, and I guess that's also the point in the one there about orientation, where to start. It's really difficult. Understanding Git beyond the basic commands, yeah, that's something which, so in fact, next week we have our second session in this series, which will be looking at intermediate and advanced Git. I guess many of you may already have signed up to come to that, but do look out for the details for that if you haven't already signed up, because that's a great opportunity to learn more about Git beyond the basics. But also that there's a point there making sure that you use Git, which is also, it's something which, especially if you're working on your own, it can be quite difficult to get into that kind of mindset of doing that. Especially if you're not used to doing it, it's something that takes a little bit of sort of discipline to use that approach. Some more things here. So great. Thank you to everybody. It's great to see all these different answers, and some really useful stuff here. So there's a point there about massive pull requests. That's a really challenging one. So if people put in huge sets of changes, it can be incredibly difficult to review them, and there is no sort of simple answer to that. If you've got something where somebody has spent 6 months working on something, and they've got a massive amount of code that they're trying to contribute into a code base, it's really difficult to deal with that. And one of the major ways to address those kind of things is actually just to have clear kind of structured approaches in place and guidance in place that ensures that people don't go and make massive pull requests. So, if people are implementing features, then there are ways that you can do that in a more kind of splitting things up into smaller blocks and contributing smaller amounts of code that are much easier to review. Of course, sometimes code changes can be quite big, and then you need more of a kind of case-by-case process. But more generally, having the best practices and structures in place that ensure that people know the problems of dealing with large pull requests is important. And actually, one of the best ways to do that is actually to be a reviewer yourself, because if you have to review yourself, then you see these problems from the other side. And so that really gives you some insight into the challenges of really big change sets. And then hopefully as a developer, it makes you kind of see that from both perspectives and work more kind of effectively with more smaller structured sets of changes. I'm just looking if there's anything else to pick out here. There's some really useful answers here. Yeah, so things like, writing tests and writing documentation, that's always something which is a challenge. And again, this is something we face, I think, as a challenge, particularly in the research community. Writing tests particularly for a large piece of code can be almost or more time consuming than writing the actual code itself. And if you're in an environment where you are writing a sort of piece of production code and you've got a big development team and you've got people who are dedicated to writing tests and people who are dedicated to handling the different aspects of the coding lifecycle, then all this becomes much easier. But if you're a researcher or a research software developer working on your own on a project and you've got not enough time and too much to do, as many of us probably face, that problem is something which you can't easily, if you've got something that needs to produce some results to put in a paper, spending all the time that you spent producing the code to get the results to again write tests for something that you don't know when you're going to use it again, it can be quite difficult to convince somebody that that's actually a worthwhile task, even though we probably know that it's something we should be doing. So this is I think is a really good point. But of course, this is often where code review can be really important, because as people make changes, if you've got somebody who's looking at the code as it's being changed, then you can help to mitigate some of these challenges, and you can help to also give people advice about the bits that they should be testing and things that they should be ensuring are done effectively. And that also comes into, I think, this point that's on the left-hand side there about deciding on design and architecture and dependencies to use and so on. So that's also how you design these things. Again, this is I think a really important issue, is that if you're working alone, all of these things become much bigger problems. If you're working in a team, you've got people to talk to, people to give you advice. You've probably got people who've got more experience and maybe people who've got less experience. And so that's I think it's something that is a real challenge. And hopefully, the more that you learn about best practices and the more that you learn about approaches such as code review, even if you're working alone, these things can help you to think about how you structure things and think about how things work. So, okay, there's a question in the chat that I'm going to take in a second, but let me just, so that's just to say thank you very much to everybody for sharing all your thoughts there. That was a really nice set of feedback and some really interesting points made. And we will, of course, have more time for discussion a bit later on. But I will go back to the slides now, and I will also just take a couple of questions there that are in the chat. So, so a couple of points here. So there's a point here in the chat about not bouncing ideas off anybody if you're working alone. And it's true that if you're a developer and you're in a team, it could be in a research team where you're the only developer, or perhaps you just work completely on your own. It's really challenging doing this kind of work, this kind of creative work where you are building and designing new code structures and thinking about the features and all of this kind of stuff. Is something which I think we all face this problem, that if you have to do it yourself, you can spend a huge amount more time trying to achieve something that actually ends up being less significant than if you had maybe a team of 2 or 3 people working together who can all bounce ideas off things and talk about. And so, and there's a really nice point there in the chat about this concept of rubber duck debugging, which is something which, this idea that if you have a sort of a rubber duck stuck to your monitor or whatever that you talk to, sometimes just actually talking through the problem, even with yourself, can give you a solution. And we probably all had this before, but I've had many occasions where I've got stuck with something and decided that I'm going to email somebody to ask them for some advice. And in the process of writing the email where I've explained exactly what it is that the problem is, I realized the solution because I've kind of put the stuff down and I've thought it through and written it down. And then before I send the email, I realize what the problem is and I delete it all and cancel it. And that's effectively this concept of rubber duck debugging. It's that having sort of a place to sort of set the stuff down yourself. So that's I think a really good point. So thank you for that in the chat. And the other thing there is there's a question about legacy code and how long would you kind of keep legacy code going, and if there are better solutions that are out there. Of course, that's something that's very project specific, but in general, there's always going to be legacy code out there because there are things that have been built over long periods of time that are valuable in various communities where they run, particularly in the scientific community. This is a challenge because there are a lot of big codes out there that do key scientific processes that are often quite old and they're difficult to. This is obviously very domain specific, I guess, but certainly in some domains it's very much the case. And it's often the problem that there isn't the resource to sustain codes, and even less so the resource to build new things completely from scratch. So you end up with things that people have been using for many years, and it gets kind of just about held together with new changes and new bits and pieces over time. There's really not, I guess, a simple answer to that, other than to say that if it's something where you have a user base and they're unhappy with the code that they have, they're unhappy with the tools being provided to them, then if you've got a strong case for addressing that, so maybe there's performance issues, maybe there's reliability issues, etc. If you get to a point where there are enough things that need changing that require your piece of legacy code to undergo several kind of iterations of processes, then it might be worth thinking about making a case for actually redoing it from scratch, because eventually you're going to get to the point where it might actually be quicker to do that, and much more effective in the long term. But of course, if you're working in an environment where there's a project or a team and people have different views about how they want to go forward, and often people are quite understandably reluctant to have fundamental changes to things that effectively do mostly what they want, that's not an easy problem to solve. So that's a good question. Thank you for that. Yeah, I hope that's also useful to other people who are thinking about these things too. Right, so with that, we'll move on, because I don't want to take up all of Steve's time for the interactive element. So a little bit on processes and practices. So we're going to focus particularly on this kind of informal code review based around code modifications and contributions. So this is kind of a combination of the modification-based review, as I mentioned before, but done in a sort of a less formalized manner, perhaps. And we're going to look at that as part of this session. And we're going to look at how you can bring code review into the research process. So, if you are working as a researcher, as I said before, or you're working on something that's research related, even if you're working alone, you can use processes that at least get you into the mindset of being able to do this kind of checking and reviewing of things. And also, aiming for a process that is lightweight and informal is something that helps to make it more practical to do. So, if you have really big heavyweight processes, a bit like the point I made before about testing, if you've got to write enough tests to ensure that you have good coverage of your code with your tests, and it's going to take you more time than it took you to write the code in the first place, then you're likely to be put off before you've even started. If you have a process that is lightweight and more informal, then it's likely to make it much easier to follow. And it's really the case that, as pointed out there, and there's a link to a book there on best kept secrets of peer code review, which it points out that if you're following a more informal process, the greatest benefits are felt in the kind of first review process and the first hour of time spent looking at things. So there are huge the benefits at the start are huge, and then they kind of sort of tail off the more time you spend going through things, because you're going to spot probably the biggest issues or the biggest challenges very quickly, and that really can give you the most benefit. So it's really worth following some sort of process, even if you don't spend time doing it to the greatest degree. You're still likely to benefit most in the first sort of part of time that you spend. And so really the point I'm making here is that this is effectively a pragmatic trade-off. We all have time limitations, and especially if you're working alone, that's a particular problem, or if you're working in a very small group. So it's useful to spend a bit of time, and any feedback that people can provide is helpful. So if you have somebody who can spend half an hour looking over some code that you've done, that's going to be more beneficial than having nobody able to spend any time at all. And any feedback is generally helpful. Okay, so The other thing that we're highlighting here is that modern or informal code review processes are not so much about finding defects, because in many code bases, there are structures in place that help you to do that in an automated manner. So if you've got things set up like testing, if you've got some things like continuous integration, and again, that's something we did a session on in the kind of the full series of Byte-Sized RSE, and you can go and find the details on that. There's a podcast available as well, and we can provide links through the Research Software Camp to point you to some of that material. These kind of things are designed to help you with finding defects. So the code review side of things shouldn't be primarily about finding defects. You might find bugs as you go through things, but it should be more about helping to improve the quality of code and the understandability and the maintainability of code. So if you have code that's very difficult to understand and you make it public, then you're going to struggle to get people to engage if you want to get people to contribute to it. You're going to struggle yourself to maintain it, because if you come back after 6 months and look at it, maybe you can't remember how stuff worked and it's impossible to see what's going on because the code is structured in a confusing manner. So a lot of these kind of review processes, as much as they can help to find defects, the primary aim is more about improving the quality and the understandability of your code. And some of the other benefits that you can get from these things, aside from this general kind of overall quality of code improvement, is ensuring that people adhere well to best practices or conventions in a project. So if you're working on a project where there are particular guidelines on how to produce code, and the structures that should be used and so on, then code review can ensure that you can make the best of that and do things properly there. And also around things like optimization, reducing inefficiencies. So maybe someone reviews some code, they see that a particular algorithm is not very effectively implemented and it could be done a different way that improves performance. And also this idea of just sharing knowledge and upskilling members of the team. There's a huge amount you can gain from getting feedback on your code, and that can really help you to get more knowledge and more skills and to move your kind of coding capabilities forward. So it can be really beneficial for that. So another thing here to point out is around how reviews are actually carried out. And so reviewers of code may follow a project checklist. So this is particularly the case if you've got sort of well-structured code review process in place for a project. There may be a checklist, and that can help to ensure consistency of reviews, so people follow the same structure each time. And also a kind of iterative process where you discuss something, you make updates, and then there might be another review process that takes place to go through that again and sort of iterate around and address things. Can also be a good sort of structure to follow, but obviously it's very much dependent on how much time is available and resources that are available. And the other thing there is that these processes may be combined with other code quality or development processes, such as pair programming. So sometimes you get cases where people sit and work as a pair, and that can really help to change the mindset of how you implement stuff. And someone who's working with you can give you ideas, and you can think about how to do things effectively as a team. That can be really, really effective as well. So just to kind of start to come to the end of this section, looking at platforms and tools, there are a number of modern source code management tools out there. You may have heard of, I'm sure many or most of you have heard of Git, but there's also things like Mercurial, Subversion, which is a much older system and used much less now. But these are all well suited to this idea of change or contribution-based code review. So they all follow a structure whereby you have a set of code, and there is a kind of process of adding changes, and there are ways to ensure that when those changes are added, that there is an ability to look at changes that are being made against the whole set of the code base, and to review those changes in isolation against the rest of the code base. And so that's really this idea of providing diffs, as they're called, that show you what's changed in a particular update, and somebody who's doing a review can then look only at those changes and see how they affect the core code base, which makes it much easier to review updates. Of course, if somebody just sends you some code as a zip file or something, as people may have done in the past before as version control was being used, then if they send you a file that's different to the one you had before, it can be extremely difficult to know what's changed. Now, of course, the diff command has been around for a long time, and that'd be something that you might have used in those circumstances to look at the differences. But these kind of modern systems bundle that up in a way that makes it much easier to see how this is all being done, and they often give you nice visual sort of graphical interfaces that show you the changes. That makes reviewing things much easier. And there's also that really links into this idea of these higher level tools that are out there. So some of these kind of tools, so there are things like Space and Crucible. They're just a couple of examples, but there are many others out there. And GitHub particularly, which also serves a similar purpose, have a lot of things that are built on top of the version control platform itself that give you these nice kind of ways of looking at code and reviewing it. And that really does make a big difference. It makes it much more efficient and much quicker to do reviews, but it also gives you the ability to exchange ideas or provide comments in a kind of asynchronous manner that's much easier than trying to do it by sending somebody an email or some other approach. So those can be really valuable, and we'll see that in a minute with use of GitHub. But there can also be project-specific workflows that may be used, and that very much depends on the sort of project or size of project you're working in. Okay, so that's all from me for now, and I'm going to hand over to Steve, and I hope I haven't gone way over time, Steve. We'll now move to the interactive element, and then after that, or indeed during that, depending on how we're going to structure it, there will be certainly opportunities to ask questions. There are several questions in the chat there, and I can come back and put some answers to those as Steve's going through the interactive session. So I will now hand over to Steve.
Okay, thanks, Jeremy. And no, that's been absolutely fine. I think we have quite an ample time actually in this session to be able to do the activity as well. So that's all for the better to spend time on this too. Okay, right. So I'm just going to share some slides. We'll talk about the activity and what we're going to do. Okay, does that look clear? Is that visible to everybody? Yeah, okay, great. Right, thanks, Jeremy. So yes, now you're going to get a chance to have a go at this yourself, and hopefully it'll be a lot of fun as well, and it'll be a nice learning journey for everyone. So the overall aim then for the activity that we'll be doing is to give you experience of code review, and then you can consider, once you've done the activity and you've listened you've considered Jeremy's talk as well, where you can consider where best to use pull requests in your own work with colleagues. And the other advantage, of course, which is really great with this, is that also then you'll be familiar with them when you do come across them. If you're planning not to use them immediately, you'll still have these tools in your toolbox to know how to handle them. You're also going to gain some practical experience of code review from two perspectives for this activity. So firstly, as the contributor, so you'll be contributing changes via a pull request, we'll be creating a pull request, and then having someone else review the changes that we make in our repository within that pull request. And as a reviewer, you'll also get some experience in reviewing someone else's pull request as well, which should be great. So I'm going to be demonstrating all of this and leading you through this via live coding. So I'm going to be sharing my screen and presenting a demonstration, and you're free to follow along with me if you wish to do so. You will need a GitHub account of your own if you wish to engage in the activity. If you haven't got one, feel free to sign up now at github.com. So you may have some time to do that before we start. And we'll be providing an existing code repository for you to use for this activity that contains some code, and indeed the repository itself that we're going to be playing with and making a couple of changes to. So just as a quick check, I just wish to see how many people are intended to participate in the live coding activity. So if I could ask those that wish to do so, if you could give me a green tick as a reaction, I could just get an idea of the scale of the people that wish to be involved. Don't be shy to get involved, but of course don't feel you have to. So this will also function as a demonstration as well. Okay, so we have a few of you who wish to do this. Okay, so this live coding activity is only a taster. There's always going to be more to learn. We're going to be providing a Google Doc, some links to further information and some guides for learning more on this topic as well. Unfortunately, due to time constraints with this activity, we're unlikely be able to solve any in-depth technical issues that you may run into. But if you do run into issues and unable to get past them, hopefully even as a demonstration, so we'll give you a taster of how code reviews are useful, how you can make use of them in your own work. So what are we going to cover in the activity today? We're going to make a copy of an example template GitHub repository in our own GitHub accounts. The repository contains a single main branch with some example code. For the purpose of the activity, it could be anything, and we're only going to be using it really as for illustrative purposes for the activity. So you won't need to run the code or anything like that. I should point out this is a common repository that we use in training sessions to demonstrate how and in what ways to improve many things. And so the quality of the code is terrifically not good, which is deliberate, I assure you. Now, once we've created our repository from that template, we're then going to add an issue to GitHub, and this issue is going to represent some unit of work, something we wish to change in our repository, and then we're going to create a fix for that issue within the repository. We'll then use the GitHub editor to do this for simplicity for this activity. In practice, of course, we may have decided to clone the repository onto our machines, make some changes, then add, commit, and push those changes back to GitHub. But for brevity and well, expediency, really, we'll use the GitHub editor to do this for the activity. And then once we've got that fixed, we'll submit it as a pull request on our new repository as well. And then what we're going to do is we're going to have a bit of fun, right? What we're going to do is we're going to swap our repository URL with someone else who's doing this activity. And we'll first add our repository URL to a shared Google Doc. And then from that Google Doc, we'll take some other participants' repository URL, and then we'll review the pull request they put on their repository. And then finally, as a reviewer, we'll write our own review of the other participants' pull request, and then we'll submit that as a review for them to consider. And then going back to our own repositories, as contributors, we'll read the other participants' review of our pull request when they've submitted it, and we'll merge our pull request into our repository. So it should be a bit of fun. Don't worry if that's not completely clear, we'll be leading it through you step by step. Okay, so let's get on to that. So what I'm going to do now is I'm just going to stop sharing my slides. And I'm just going to resize a couple of windows and share another window. I just need to make sure I get this right. Okay, so what we're going to do is, the first thing I'm going to do is I'm going to put a link to some session notes that we'll be referring to at various points throughout the activity. So there's a link to a Google Doc you'll find in the chat now. And if you open that, you'll see that there's a list of links at the top. Okay, so what I'll next do is I will copy and paste the URL of a repository into my browser, and I'll make sure you have access to that at the moment. Let's make sure that we get hold of this in the right way. Okay, right, now I just need to share my screen again. So let's do that. Okay, does that look reasonably clear? Are people able to read that? Good. Okay, thank you very much. So yes, the first thing we're going to need to do is to make an example GitHub repository we'll use for the activity. And to do that, what we're going to do is we're going to create a new repository from this template repository. So what I'm going to do is I'm going to put that into the chat, so you can go straight to that repository. There we go. Okay, so first thing we're going to do is we're going to clone this repository into our own account. So we're going to click use this template and create a new repository. And then we'll be presented with this screen to do just that. And what I'm going to do is I'm going to call mine exactly the same name, but feel free to use any other name that you like. Just remember what you call it. The other thing we need to do is make it public so that we can have someone else review this repository. Okay, so what we do is we then, once we've done that, we create the repository from the template that we should be presented with, assuming GitHub's not having a snooze, which can sometimes happen. Should only take a few seconds, and this time it actually did, which is great. We should find we have our own copy of this repository now sitting in our account, which is great. So a very quick progress check. So I'd just like to see if those who are doing the activity, if you've managed to make a copy of that repository, if you could do a green tick for yes and a red tick for not quite yet, we can see how people are getting on. Okay, great, excellent. Right, okay, oh, so one still waiting. So we do have some time, so happy to wait a bit. Okay. Right, okay, so the next thing we need to do is add an issue to our repository. So what we're going to do is we're going to create this issue which is going to represent something that we would like to work on this repository. And this is good practice. So what we're doing is we're thinking of the things that need to change in our code base. We can add issues to represent the things that we would like to change. These could be bugs, these could be enhancements to documentation, these could be all kinds of things we would like to see changed. Could be some kind of enhancement to the interface, anything like that. For the sake of this exercise, I mean, it's not going to matter too much what the exercise is, what the issue is, but it could be that, you know, we'll have a look around our repository and have a look for an issue. So one I think that does exist is if we have a look at this link here, if we click on this in our README, we can see that the link doesn't actually work. It's a broken link, and what we could do is try to fix that link so that it works. So what we can do is we can create an issue to represent that unit of work that we wish to do. So let's do that now. So if we click on issues on our repository and then click on new issue, and we noted that there was a broken link. Oops. I hope your typing is better than mine. Research fish article. And the description, you don't need necessarily to write what I'm going to write in here, but you could write something a lot shorter if you like, but I'm going to put in some detail of the issue. So essentially when I'm writing a good issue, what I like to do is to explain the nature of the issue itself, how to replicate it. So in this case, I'm saying the link is broken, which results in a page not found error. There we go. So I'm precisely describing the error condition of the problem that we have. And then once you've done that, we can click submit new issue. Now, the other thing that's really good with GitHub is it gives us the opportunity to do a number of other things with this issue as we're editing it, indeed, as we're creating it. And one of those things we can do is we can assign it to someone. So what we're going to do in this instance, we'll assign it to ourselves. We could assign it to someone else if we wished, but in this case, let's just keep it ourselves. Now, the other thing is that we can also assign a label to the issue as well. And labels basically are a way for us to categorize what the issue is, what kind of thing it is. It could be a number of things. It could be one thing, but in this case, I think it's fair to say we could argue this is documentation. This is to do with the README file. So let's select documentation to classify this issue. There we go. We should see that. So now that we've done that, we've created our issue, we've assigned it to ourselves, we've set it labeled, so what kind of category of issue that is. Right, just going to ask, let's see, ask everybody just to give me a green tick if you've managed to get to that point, or we proceed further. Red cross if you haven't yet been able to. Great. Okay, right. So let's proceed. So the next thing, perhaps a bit later on, we're going to decide to perhaps as a future date, we've made these issues. We now have these reminders in our repository of the things we'd like to see changed. And of course, these issues could be created by ourselves. It could be created by our collaborators, our users, so on and so forth. But now we've decided at some future date we want to fix the issue. So we navigate to the README. So let's see if we can actually do that change and fix that problem. So we're going to navigate to the README. So yes, as we said, we're going to use GitHub's edit mechanism to make that fix. So we click on the README file that's there in the root of the directory. And then once we've done that, we can go to edit icon and click that to edit the README to fix the link. Now, as you said, another way of doing this would have been to clone this onto our machines, make the change there in an editor, add, commit the file change, and then push those changes to GitHub. We're going to use the editor here just for expediency. So now we can fix the issue, and you will notice that there is something in the link which is typo /, which perhaps unsurprisingly is the typo we wish to correct in our link. So if you can hopefully see that, is that large enough text, perhaps you can see it now. You should see in that link it says typo /. Someone asked in the chat, a very good question actually, yes, are there any pros or cons to doing it directly on GitHub rather than going to your machine? So yes, sometimes doing it directly like this is a way to do very quick changes, particularly in things like documentation that you spot and you need to change. So very small changes, editors very good for that. The other really good thing, particularly with documentation and Markdown, is it gives you this wonderful way of previewing your change before you actually commit it, which is absolutely marvelous. For larger changes, I would probably recommend doing something on your own machine, cloning the repository on your own machine, making the changes there, particularly when it comes to code. One thing I wouldn't recommend is probably to be avoided would be to make changes to code that's sitting in the repository using GitHub Editor, because you don't then have an opportunity to vet your changes as you're making them on your own machine to check they're actually working. And even for apparently, for obviously simple changes, sometimes that's still not a great idea. So if you're making changes to code, very good thing to do is once you've made changes, verify them. If you have any unit tests, run those tests. If you don't have those tests, or even if you do, manually run the code yourself to check that the fix is actually working on your own machine before you commit the changes. And that's a really good kind of practice to get into. Edit code, run tests, manually check everything's in order before you make those changes and commit them. And that's something that's best done on your own machine. So that's certainly one thing to consider, but a great question. So once we've done that, what we can do now is we can commit the change. So now we can go to commit changes here in the top right. Good practice when committing a change is to refer to the issue number in the commit message as well. So it's come up here and said update readme in the commit message, which isn't particularly enlightening as to what it is we're actually doing. So what I'm going to do is I'm going to, as I said, refer to the issue that we're correcting, which is issue 1 in our repository. I'm going to say fix broken article link. Now we could actually put some more information here into the description, but for brevity, I won't actually do that. Now, importantly, what we want to be able to do is to have this change reviewed by another, and a way that we can do that is we can create a pull request, and that's really the accepted practice for doing this within GitHub. So what we need to do is we need to create a branch which has this change upon it, and then from that branch we create our pull request. So in order to do that, we need to submit this change on a new branch of GitHub. So if I just select the second option there, create a new branch, let's commit start pull request, and within that we can give a meaningful name to our branch, and indeed I could keep it as that. Steve Crouch is making a patch, first patch for issue 1, but I'm going to change it to be something else, which is readme broken link fix. And yes, I'll put the issue number as the first thing there like that. And of course, when you're working in a team or working with others, it's a good idea to decide on what your strategy is going to be as to how you name your branches when you're making code changes, when you're making pull requests, so that when there are a lot of pull requests that are sitting waiting to be reviewed, it's relatively obvious which ones are for what issues and what they're roughly about. So it's a good thing to talk with people within your team and decide how best to proceed in terms of that strategy. So right, so once you've done that, and also to be consistent as well in that strategy too. So now what we're going to do is, once we've done that, we can select propose changes. Now this change will be submitted and our new branch will be created with that fix upon it, and we can see that here. So again, a quick question. So who's managed to commit their fix on a new branch and got to this stage? Green ticks if you've managed to get that far. Red crosses if you haven't quite got there yet. Okay, great. So now we've got that. We now have our branch, and we now have our commit on that branch, which we can see down here. If we scroll further down, we can see that on this branch we have one commit, and we can see that we have this change actually highlighted here, which is really useful within the one file which we've changed. But we still need to submit the new branch and the commit that's upon it as a pull request, so it can be reviewed. And GitHub nicely guides us to doing this with the magic button, create pull request. So let's go ahead and do that. So we'll create our pull request. And we can see, once we've done that, the nature of the pull request. We can see this here. We can see there is one single commit on this pull request, which is the one we've made. We can also see the files that have changed, the nature of those changes within the commits that are currently sitting within that pull request. Okay. And the other interesting thing is, which is really useful, and GitHub does this really quite well in the background, is it tells you if there's any conflicts with the base branch. We have our we have one branch, which is our main branch of the repository. That contains the branches, the commits that exist on that branch, on the main branch. And we've also created this new branch, which contains this one single commit. And what it's telling us is that there are no conflicts with the main branch. And if we wanted to merge this change into the main branch, we could do so. And apparently there wouldn't be any issues. There are no conflicts. There are no issues or changes that have been made on the main branch that conflict with this change. So we won't do that just now. But what we'll do is I will ask, see who's been able to create a new pull request from that. Who's managed to get to that stage? So green ticks again if yes, red tick if no. Okay, right. So what we're going to do now is we're going to swap our repository with someone else. This is the fun part. So what we'll do is we'll go to the repository's main page. So we just click on here where it says review example at the top. And then what I'd like you to do for those that are involved in the activity is to go to the document I'm going to put to the chat, which hopefully you should have access to. And it should look a bit like this. So what I'd like you to do is to take the URL that you have from your repository, just copy it into your buffer there, then go over to this document, this shared document, which is, yes, also linked to in the session notes as well. So if you go to that and you copy your URL, as people are already starting to do, into that first column of the repository that contains your pull request, then once you've done that, if you could just put up a green tick, just so we can see who's done that. So we can see 1, 2, 3, 4, 5 repositories. Okay, so that's looking good. Are there any others that people would like to volunteer into this document? No. Okay, that looks good. So the next stage is to take someone else's repository. So a little bit of a tricky one, this. But what we've done is we've created a second column. So if you would want to review someone's pull request on their repository, if you just put a Y into that column, one that hasn't already been taken ideally. And I see that there are 6 involved in the activity. So fortunately, that's a nice even number. So we should have all of you able to do that. But if there isn't, feel free to let me know. Someone else. Okay, looks good. Oops. Right, okay, so that looks great. So if you now copy and paste that repository that you have claimed for your review into your browser and open that. What we're going to do now is we're going to adopt a new role, right? We're going to be the reviewer of a pull request. So let's assume that our colleague has created a pull request of his own on their repository. And what we want to do is perhaps it's on a project that we're working on or something like that. And in this collaborative environment, our colleague would like us to have this pull request reviewed as is good practice. So let's actually do that. Okay. So we open the repo URL. I'm going to pretend that I've taken someone else's, and here we go. And what we can do is we can go to, we can select the pull requests tab at the top of their repo, which should say pull request. You should see there's one pull request sitting on it. So if you go to that, you should be able to see the list of pull requests. There should be one pull request. We click on that pull request and we see the nature of that pull request. Unsurprisingly, it might well look very much similar to the one that we have on our own repository. So no surprises probably here. Unless someone's got adventurous, of course, and decided to fix something else. And indeed, there are many things that are wrong on this repository. Deliberately, I can assure you. Right, so now we have this. Let's see, just make sure that everyone's been able to get to that state. So if you throw a green tick up or a red tick or sorry, a red cross, I'll just indicate if you've been able to do that for those involved in the activity. So what we're going to do is we're going to, that's great. Okay, so now what we're going to do is we're going to create a review on that repository, on that pull request. So what we do is we click on the Files Change tab of the pull request. And you'll see that it should show something that looks something like this. And you can see that on the left, on the red version, this is the old version of the file, and we can see the nature of the change. On the right there, we can see the typo has been removed. Okay. So now what we do is we have the option of adding comments or suggestions in line to the proposed changes if we want. So let's do that. Let's actually start our review. So if we, for example, would scroll down to this line here, we will hover over this and you will see that we can make change. We can make comments on each of any lines that we wish within this. And what we'll do is we'll leave a comment here. And this will enable us to start our review. So once we've done that, we can add our comment. So we've selected change the line, and now we can add something like, you don't necessarily have to add all of this in. But perhaps what's happened is, we think this is a good change, but we also think that, perhaps there's something else we should add in here. So we should also add in a link to the Zenodo record code that this article links to. And perhaps what we could do is we could supply a URL, and again, I don't expect you to be able or wish to put this in, so feel free to just put in something, just a rough comment. And then once you've done that, we can click on this to start our review. So what we're doing now is we're basically putting that comment as a review comment within this pull request. And indeed, what we can do now is we can go through, if there are more changes, more files that had changes, we can go through and add comments as we wished on this pull request. But let's assume that we're now complete. So finally, as a review of the pull request, we can finish our review. So if we got to finish review and click on that. And what we can do now is we can leave a comment and we can decide how we would like this to proceed. So we can say something like, overall, let's see, the changes look good. Of course, this could be a much larger pull request that we're reviewing. So, having a summary comment at the top is a really good way to start a conversation about the pull request itself and what may need to change, and including this issue here that we think perhaps is the greatest issue that needs to be considered. So the other option, of course, we can create a separate issue. Perhaps we know that the person who's working on this particular aspect of the code base was intending to do this. Perhaps it's something that's missing. So we're just basically highlighting this as part of this pull request. And we then have three options. We can decide to either just comment on the pull request. We can just leave a comment to consider for the person who's created the pull request. We can approve the pull request. We can say, yes, it's approved as it is. No changes need to be made. Or we can ask that the contributor, we can ask them to make some changes. We can request changes. So there are some aspects that must be addressed before it can be merged in and accepted into the code base. But for simplicity, what we'll do is we'll go with the first option for the exercise. So we'll just have a comment. So this is a way to classify our code review. And then once we've done that, we submit our review. And now we've done that, the other participant can then take our review into account when deciding whether to merge that pull request. So now we've got through that. That's probably the trickiest part of the exercise so far. Let's see how people are getting on. So if those involved in the activity could again throw a green tick, see, or a red cross. Let's see who's got to that stage. Okay, great. Okay, so now we've done that, we can now do the final steps. So we can go back to our role as contributor. So pulling back from our colleagues repository, if you now go back to your own repository, hopefully what you will see, and I'm going to pretend that that's what I'm doing as well, we should find, so going back to our own repository, that on our pull request, we should see, fingers crossed, someone's left a comment, a review on this pull request, which is something, you should see something along the lines of this. And of course, at this stage, what we would do is consider the review, any observations or the suggestions made. And at this point, we can go ahead and make any needed changes, including the one for adding in that Zenodo link. But for simplicity, and assuming their review is essentially accepting the nature of the pull request, we can go ahead and merge the pull request into our code base. So we've had the discussion, and a discussion within a pull request in terms of the reviews that are being made. Could go on for a little while. It could go on for perhaps another, perhaps you have 2 people that you wish to get feedback on this pull request. You're making changes to your code base that is affecting the code base in aspects that other people are working on. And we could include both of those individuals perhaps on this code base pull request, so we can get their thoughts on this and provide their own reviews. And let's assume that we've done that, and now we can merge it. And of course, we don't have any branch conflicts with the base branch on this pull request, so we can go ahead and click merge request. So now that change that we're going to commit will be merged into the main branch, and we can go ahead and click merge, found the merge, and it also then tells us pull request has successfully been merged and closed, which is great news. Now, the other thing we should consider is a little bit of housekeeping, because you can see here what it's doing is it's suggesting that we delete the branch now that this has been essentially merged into the code base. And it could be that this is the natural stage at which this pull request can end its life. It's served its purpose. We've had our code reviews in, we're happy with that, and we've merged it into our code base. Under that assumption, what we can do is we can think about a little bit of housekeeping. So if we go to branches, so if we go back to the main repo and click on branches, you should see there are 2 branches there. The main one, which now contains all the changes, and our fixed branch, which is sitting here, which is the one we've merged from. Now, this has already been done. We've completed this, and it doesn't need to be around anymore. So a good thing to do is to clean up our branches that we don't need. When you have a repository with certainly a few or more collaborators making a lot of pull requests, the number of branches that exist can grow quite substantially and can become a little bit problematic in terms of understanding what's active and what isn't. So what's a good thing to do? A good practice is to delete those branches that we don't need anymore. So what we're going to do is we're going to click the trash icon here, which deletes that branch so we no longer need it. And then we should find that we just go back to our single branch now. We just see this has been deleted, and we are back to essentially having our one branch from which we can create new pull requests, commit new changes, so on and so forth. Okay, right. Thank you very much for that, for those that followed along. I hope that was useful. If you just were admiring it or just having a look at it in terms of a demonstration, I hope that also was useful for you too.